We will look at using the air conditioning system during a normal flight. As part of the aircraft walk-around, check that the pack inlet and outlet areas are clear of debris and the ram air valve is closed. Let's assume that you are about to start the flight. The APU is running and you require air conditioning. You are now in the cockpit, and this is how you find the air conditioning panel during your scanning sequence. Notice that, except for the off lights on the two pack push-button switches, all other push buttons are in the normal lights out position. One of the items in the cockpit pre-flight check is to extinguish all white lights on the overhead panel. So that you can watch what is happening, let's have a look at the ECAM bleed page. Call the ECAM bleed page. Now extinguish the Pack 1 off light. Switch Pack 1 to on. Notice the amber fault light on the Pack 1 push-button switch. The control valve indication switching from green to amber. Both of these amber indications occur because Pack 1 is on, but no bleed air is available to it. Switch Pack 2 on. As for Pack 1, notice the amber fault light on the Pack 2 push-button switch. The control valve indication changes from green to amber. As before, there is no available bleed air to Pack 2. Since you are expecting a standard passenger load, the pack flow selector can be selected to normal. Set pack flow to normal. There are no changes to the ECAM indications. The pack flow selector only affects the pack flow rate once the engines are running and supplying bleed air to the packs. We will look at the use of the pack flow selector later in this module. It is now time to get some air to the packs. As the APU is already running, set the APU bleed to on and watch the ECAM indications. Switch APU bleed to on. Notice the APU valve indication has changed to inline green. The cross-bleed valve has automatically opened. Notice the cross-bleed selector is in the auto position. Both feed lines to the packs have been connected. Let's now look at the packs. Notice the fault lights are extinguished due to the air supply. The pack flow valves are open. The pack flows increase. The bypass valves move. The supply lines to the mixing unit are now connected. Both packs are now providing air conditioning. Let's look at temperature regulation of the air conditioning system. This is better seen on the ECAM COND page. Call the ECAM COND page. Let us concentrate on the upper part of the ECAM COND page. Look carefully at the indications. Notice in particular the zone temperatures and the duct inlet temperatures. Temperature regulation is achieved the same way for all zones. We will demonstrate the concept using the cockpit zone as an example. The cockpit zone temperature selector is in the 12 o'clock position. In this position, a zone temperature of approximately 24 degrees Celsius is demanded. As the 15 degrees Celsius of the cockpit zone is well below the demanded 24 degrees, the zone controller sends a command to increase the amount of hot air to be added. Due to this command, the trim air valve opens, the zone duct temperature increases, and so warm air is supplied to the cockpit zone, and the cockpit zone starts to warm up. Once the cockpit zone reaches the demanded temperature, the trim air valve will move, reducing the amount of hot air, and then will move as required to maintain the zone temperature. It is now time to start the engines. So that you can watch what is happening, let's go back to the ECAM bleed page. Note, normally the engine page is displayed during engine start. For training purposes, we will display the bleed page. Call the ECAM bleed page. Let's start the engines. Be sure to watch the pack valves on the ECAM bleed page. Click on either engine. As soon as the engine start sequence begins, the pack valves close. This is so that all of the APU bleed air can be used to start the engines. Let's complete the sequence. When the engine starting sequence is completed, the pack valves open and the APU bleed supplies the packs. Notice that the engine bleed valves are closed, even with both engines running. This is because APU bleed has priority over the engine bleed. So, if you are departing from a performance-limited runway, the packs could run from the APU bleed air, resulting in no loss of engine performance, no weight penalty. However, today, in our example, the APU is no longer required. Switch off the APU bleed. When the APU bleed push-button switch is selected off, both engine bleed valves open, supplying the packs with bleed air. The APU bleed and cross-bleed valves close, and the link lines disappear. Notice that the pack flow reduces. This is because the engines provide a higher flow rate than the APU. Also note that the air conditioning control panel is now in a normal lights-out configuration. When the APU is shut down, the APU symbol on the bleed page is removed. During the flight phase, the air conditioning system will work automatically, and the only likely pilot input that may be required is to adjust zone temperature. Let us assume that you wish to cool down the cockpit. To demonstrate, please select the cockpit zone selector to cold. You have now demanded a cockpit zone temperature of 18 degrees. Because a low temperature has been demanded, the trim air valve will close and the cool pack output will feed the cockpit zone. Note that each increment on the zone temperature selector scale is 2 degrees, which gives a selectable range from 18 degrees at cold to 30 degrees at hot. In situations of low passenger numbers, the pack flow selector can be set to low. This has the effect of reducing the bleed demand from the engines and will therefore save fuel. Occasionally, with a full passenger load and high ambient temperatures, it may be necessary to select high pack flow and cold to reduce the cabin temperature. Using high pack flow will increase the bleed demand from the engines and use more fuel. Once airborne, the flow selector should be returned to normal and the temperature selectors adjusted as required. After landing and engine shutdown, the system can be set to run from the APU or switched off completely. An external conditioning unit can also be connected via a low-pressure connection point on the underside of the aircraft. The low-pressure air is fed to the mixing unit and then into the 3 zones. There are no indications in the cockpit to show that an external conditioning unit is in use.